Hi, I'm Professor Mary Ann Barber. In this example, we will integrate a function. Calculate the integral of dx divided by the square root of the quantity 3 plus 4x minus x squared. In order to solve this problem, we will need to complete the square of the expression under the square root so that we can make it fit one of the Trig expressions. So let's look at 3 plus 4x minus x squared. As a reminder, remember that when we complete the square, it's easier to list the terms in decreasing power of degrees, and then the first coordinate has to be positive, so if you factor out a negative, you get x squared minus 4x minus 3. Now, what we're going to need to do is find the term such that when you add it, it gives you a perfect square with the x squared and minus 4x. Now, if you add a number to an expression, you must also subtract that same number in order to ensure that you don't change the value. This value here is half of the middle term squared. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4. And we will also add that or subtract it to the same place. This then will simplify to x minus 2 quantity squared minus 7. Now, we can distribute the negative and you would get minus the quantity x minus 2 squared plus 7. We'll replace that in the original integral problem and write it as the integral of dx divided by the square root of 7 minus x minus 2 squared. This using the formula for sine inverse or arc sine is going to be the arc sine of the x term, which was squared, divided by the square root of 7 plus c. Okay. As a reminder, we use the integral du over the square root of a squared minus u squared is the sine inverse of u over a plus c.